GEnx-1B MPD and AMM, and GEnx-2B MPD and AMM, as well as GEnx-1B Service Bulletin 72-0267 and GEnx-2B Service Bulletin 72-0233, call for a borescope inspection of the high-pressure turbine, or HPT Stage 1 rotor blades. Cracks have been observed on the convex airfoil of HPT Stage 1 blades. The cause of the convex airfoil cracks is a combination of flight cycles and accumulated time at high temperature. This digital training aid demonstrates how to inspect the convex side of the GEnx high-pressure turbine Stage 1 blade root area where axial cracks have been observed. Always be sure to use the latest version of the aircraft maintenance manual for the defect limits when performing this task. Do a borescope inspection on the convex surface of the HPT Stage 1 blade airfoils in Area B to look for axial cracks immediately above the HPT Stage 1 blade platform. Cracks must be carefully identified because they can be very small. GEnx-1B Service Bulletin 72-0267 and GEnx-2B Service Bulletin 72-0233 request that you record the borescope inspection as a video and supply a copy of the inspection of all 62 HPT Stage 1 blades to your GE Field Service Engineer, or contact the GE Aviation Operations Center. You will apply the serviceability limits from the Boeing 787 AMM or 747-8 AMM, Chapter 72-00-00, High Pressure Turbine Section with a borescope, Special Detailed Inspection Section, with the exception that GE must be contacted before the next flight for continuing service recommendations if cracks longer than 300 thousandths of an inch or 7.62 millimeter are found, or if any blade has more than one crack. Inspect the convex side of the HPT Stage 1 rotor blades in Area B for axial cracks. Turn the rotor slowly so you have time to look for these axial cracks, as they can be very small. If an axial crack is detected, stop the rotor and move in for a closer examination. Sometimes you can determine that the metal beneath the thermal barrier coating is cracked by looking for the trail of darkened TBC above the crack. This indicates that cooling air is escaping from the blade internal cooling cavity and that the metal of the blade definitely has a crack. Keep the platform cooling holes in the view if you can. You can use the spacing of the cooling holes to help determine the length of the defect. The cooling holes of the platform are 170 thousandths of an inch, 4.3 millimeters apart. No cracks are permitted. However, there are continuing service limits that allow continued engine operation at reduced interval repeat inspection. If it is a crack, you need to determine the length of the defect. A length of 100 thousandths of an inch, or 2.54 millimeters or less, requires reinspection at 100 cycle intervals. A length of 200 thousandths of an inch, or 5.08 millimeters or less, requires reinspection at 50 cycle intervals. An axial crack that turns in a radial direction is not permitted and requires engine removal within 10 cycles or less. A crack length of over 200 thousandths of an inch, or 5.08 millimeters, requires engine removal within 10 cycles or less. GE must be contacted before the next flight for continuing service recommendations for all convex axial cracks found to be 300 thousandths of an inch or 7.62 millimeters or longer, or if any blade has more than one crack. After the inspection is complete, return the aircraft to its usual condition.